Have you ever looked at a mountain range or a winding river and just wondered, how did it get that way? Why does it look like that? Well, believe it or not, there's a whole science dedicated to answering those questions. It's called geomorphology, and it's basically the science of scenery, how our world gets its amazing and varied shapes. Right? These are the kinds of questions we're talking about. Why are some mountains these sharp, jagged peaks, while others are gentle, rolling hills? Why don't rivers just take the shortest path? These questions, they're the absolute heart of geomorphology. It's all about learning to read the story that's written all over our planet, in the rocks, in the soil, in the water. So, here's our game plan. We're going to start with what this science of scenery is all about. Then we'll get into the big engines that drive everything. After that, we'll check out the main tools the planet uses to sculpt itself, water, ice, and wind. And we'll wrap things up by looking at our own growing role in all of this. All right, let's jump right in. Section 1, the science of scenery. So what is geomorphology really? Okay, so here's the textbook definition. It sounds a little dense, but it's actually pretty simple. Geomorphology is the science of how landforms get made, and that includes everything from the tallest mountain to the deepest parts of the ocean floor. But the key thing to remember is it's not just about what a feature looks like. It's about its entire life story, how it got there, how it's evolved, and what's changing it at this very moment. And to really get a handle on this, geomorphologists kind of have two modes of thinking. There's the functional approach, which is all about the now. It asks, how is this working right this second? Then you have the historical approach, which is like being a detective. It asks, how did this place get to be this way over millions of years? You absolutely need both to get the full picture. This all boils down to what you could call the three pillars of geomorphology. Think of it like a stool with three legs. You take one away, and the whole thing falls over. You've got form. What does it look like? Simple as that. Then you have process. What's actually doing the sculpting? Is it water, wind, ice? And finally, history. What's the backstory? What happened here over time to create what we see today? Okay, so we've got the sculptor's tools, but what's the engine driving those tools? Let's move on to the really big picture stuff, the planet's driving engine. These are the massive forces behind it all. At its heart, geomorphology is really the story of a giant tug of war. On one side, you've got these incredible endogenic or internal forces. They come from deep inside the Earth, and their whole job is to build stuff up. We're talking volcanoes, mountain ranges, the works. But on the other side, you have the exogenic or external forces. These are powered by the sun, and their job is to tear everything back down. This epic, constant battle is what shapes our world. So let's start with the ultimate builder, tectonic activity, the slow, unstoppable drift of the Earth's plates. I mean, this is the force that creates the continents themselves. It's like the artist stretching a giant canvas, getting it ready for all the other smaller processes to come in and paint the details. And think about what this one process does. When plates smash together, you get massive mountain ranges, like the Andes, just pushed right up into the sky. When they pull apart, the ground splits open, creating huge rift valleys. And all of this grinding and shifting, well, it powers the volcanoes that literally build new land from the inside out. It's incredible. Okay, so if tectonics sets up the giant canvas, climate is what decides which paintbrushes get used. Climate is the boss of all those external, tearing down forces. It's what determines if a mountain is going to be carved up by rivers, ground down by massive glaciers, or slowly sandblasted away by the wind. So how does all this change actually happen over long periods? Well, it brings us to a really, really important idea in geomorphology, the magnitude-frequency concept. And it's simple, really. The amount of work done on the landscape depends on two things. How big an event is, that's the magnitude, and how often it happens, that's the frequency. Now, this leads to a conclusion that might actually surprise you. We all tend to focus on the huge, catastrophic events, right? A once-in-a-century hurricane or a 1,000-year flood. And yeah, they cause massive change in a short time. But what Woolman and Miller figured out is that over the long haul, the real work, the heavy lifting, is done by the smaller, more boring, everyday events that happen all the time. Here's a great way to think about it. You have one massive, catastrophic flood. It rips through a valley, causes huge damage, moves a ton of rock, but it only happens once every few hundred years. Now think about the river's normal, everyday flow. It's just moving a few grains of sand here and there. Doesn't seem like much, right? But it does that every single day. add up all that work over 100 years, and it turns out that the steady daily flow often moves way more material than that one big flood. Persistence, it turns out, really is key. All right, we've got our engine, tectonics, and climate. Now it's time to look at the sculptor's primary tools. We're talking about weathering, erosion, and deposition. These are the actual processes that do the work of breaking things down, moving them, and building them up again somewhere else. First up is weathering. Now, the absolute key word to remember here is in situ, which is just a fancy way of saying in place. Weathering is rock breaking down right where it sits. It's not moving, it's just crumbling. The movement part, that's called erosion, and it comes later. This distinction is super important. And weathering comes in a few different flavors. You've got mechanical weathering, which is just brute force. Think of water freezing in a crack and splitting a rock like a wedge. Then there's chemical weathering, which is all about reactions, like how oxygen causes a rock to rust from the inside. And finally, you have biological weathering, which is pretty amazing. That's life itself doing the work, like a tiny plant root forcing its way into a crack and eventually splitting a huge boulder. So you can think of this whole system as a giant conveyor belt. Step 1, weathering, breaks the rock down into smaller pieces. Step 2, erosion is when an agent like water or wind comes along and picks that material up. Step 3, transport. That material gets carried away, sometimes for hundreds of miles. And finally, step 4, deposition. The water or wind loses energy, drops its load, and starts building up a completely new landform, like a beach or a delta. Okay, let's see this conveyor belt in action. And we have to start with the most powerful and widespread sculptor on planet Earth, water. We're talking about fluvial and coastal systems. So fluvial systems, that's just the sciencey term for anything related to rivers. And rivers are the true workhorses of our planet. From a tiny little creek up in the mountains to the enormous Amazon River, they are constantly, tirelessly moving sediment from high ground down to the sea. And if you want to understand any river, you first have to understand its drainage basin. This is like the fundamental building block of the landscape. It's the entire area of land where any water that falls, rain, snow, whatever, all gets collected and funneled out through one single outlet. It's the organizing principle for the entire system. And the landforms rivers create are just amazing. Those classic S-shaped curves, meanders, they form because the river erodes the outer bank and drops sediment on the inner bank. You get huge river deltas when a river hits the ocean, slows down, and just dumps all the mud and sand it was carrying. Same idea with alluvial fans. A fast mountain stream hits a wide, flat valley, slows way down, and drops everything. Every one of these is a story about moving water losing energy. All right, so from the rivers, let's head to where most of them end up, the coast. This is one of the most energetic and constantly changing places on the planet. It's a nonstop battleground between the land and the sea, and the rules are written by waves and tides. And one of the most important things happening here is a process called longshore drift. Check this out. Waves almost never hit the beach straight on. They come in at a slight angle. So the water pushes sand up the beach at an angle, and then gravity pulls it straight back down. This little zigzag, repeated thousands of times a day, creates a river of sand that is constantly flowing along the coastline. And this river of sand is basically the main architect of our coastlines. It's what builds those long, skinny sand spits that stick out into the water. It's what supplies the sand for our beaches and dunes. And sometimes you can find features like raised beaches, which are literally old shorelines left high and dry, giving us this incredible window into the past. So water is definitely the king when it comes to sculpting the Earth, but it's not the only game in town. In the planet's coldest and driest corners, two other major players step up, ice and wind. Let's look at glacial and aeolian systems. First up, ice. You can think of glaciers as rivers of ice, but they are so much more powerful. We're talking about forces that act like planetary-scale bulldozers. They just grind and scour the landscape beneath them, plucking up rocks the size of houses and carrying them for miles. And the evidence they leave behind is just spectacular. They push up huge ridges of rock and debris at their edges, called moraines. They carve these massive, deep, U-shaped valleys that, when the ice melts and the sea level rises, become the stunning fjords we see in places like Norway. They even leave behind these snake-like ridges called eskers, which are the fossilized remains of rivers that used to flow underneath the ice. And hey, it's not just about the massive glaciers themselves. In the areas around the ice, these periglacial zones, the frozen ground itself creates some really unique and bizarre landscapes. The star of the show here is permafrost, ground that stays frozen for at least 2 years straight. The weird thing is the very top layer can thaw in the summer, and this constant freeze-thaw cycle can heave the ground and sort rocks into these amazing geometric patterns. As you can imagine, these landscapes are super sensitive to changes in our climate. Okay, so from the frozen parts of the world, let's go to the windy parts. We're talking about aeolian systems, the power of wind. Wind becomes a major player anywhere there isn't much vegetation to hold the ground down. So think deserts, but also coastlines. The wind is an amazing sorter of material. It can only lift the small stuff. It picks up sand and piles it into these huge sculpted dunes. It can carry even finer material, silt, for thousands of miles, depositing it in thick blankets called loess, which makes for incredibly fertile soil. And in the desert, when it blows all the sand and silt away, it just leaves the bigger rocks behind, creating a surface called desert pavement. So we've talked about the big 3 natural forces: water, ice, and wind. But over the last century or so, a new geomorphic agent has entered the scene. One that's become so powerful, it's starting to rival and in some cases overpower all the others combined. And that agent is us. Welcome to the Anthropocene. This brings us to a whole new field, anthropogenic geomorphology. And the core idea is pretty staggering. Humans have become the #1 force shaping the surface of the Earth. Get this, when you add up all our construction, our mining, our farming, we now move more dirt and rock every year than all the rivers in the world combined. Let that sink in. And you see our fingerprints everywhere. We build cities, paving over the land and completely changing how water flows. We build massive dams that trap sediment, which literally starves coastal deltas and makes them sink. We dig colossal mines and straighten out rivers to fit our needs. We are actively and fundamentally changing the geomorphic rulebook. You know, this isn't some brand new idea. Way back in 1970, a geographer named E.H. Brown put it as simply as possible: man shapes the Earth. And in the 50-plus years since he wrote that, it has only become more and more true. And that really leaves us with one final, very big question. For millions of years, the power to sculpt this planet belonged to tectonics, to water, to ice, and to wind. But now, that power is, for the first time, in our hands. We aren't just living in the landscape anymore, we are designing it. So the question we all have to ask ourselves is, now that we're in charge, what kind of world are we going to build?